Okay, question 5. A student uses a plotting compass, that's that there, to investigate the magnetic field between the poles of 2 bar magnets. The student places the magnets on a piece of paper and then they place 20 plotting compasses, which we can see here. And it says draw 2 right angles. So the first thing is we can see the magnetic fields are going into the end. So if I was to place a magnet here and a magnet there, we've got nout and sin. So we know if the magnetic fields are coming in, these must be south poles. And that's it drawn. So it's 2 magnets drawn together with these coming through. Now, if we were to have, say, a plotting compass here, we would obviously see that we've then got the butterfly, butterfly, straight, curve, curve, and those going out. The student wants to determine the shape of the magnetic field for a larger area. Okay, no problem. We've just demonstrated that. Let me get rid of all these doodles. And we said we've got a magnet there. Describe how they continue the investigation, just use 1 plotting compass. So what we'd do is we'd place the compass there, look at where it goes, and then we'd just take it off the page and show that arrow. So off goes that, put it here, show that, take it away, and we'd get that, and then we could just plot all of the arrows to show us what's going on. So that's it in short. Pick it up, place it down, draw your arrow, put it to another place nearby. So place the compass on the piece of paper and mark the direction of the field. So that is draw a little arrow. Follow the field from that point with the compass and mark the point. So we know, so what we're saying here is that tells us the direction which to place the next one and the next one and the next one and the next one. And we can just follow it round and do the same here. And we're just drawing out arrows each time. Connect up the field lines to show the shape. Done. 2 long thing magnets are held with their north poles facing each other, and the force, which will be repulsion, can be calculated using this. So I'm going to turn it into a triangle because the K is on the top there. I'll put that there, and then we've got F and D squared here, and it says calculate the value of K. So we can see K equals FD squared. The other way of doing it is I want to find K. At the moment it's divided by D squared, so multiply both sides by D squared. So we know that K equals FD squared. So the magnets are 4 centimeters apart and 1.2 newtons. But we can see here that I can use whatever unit I want. So I could change it and have Newton meters, or I could leave it and have Newton centimeters. So I'm going to change it and use Newton. Sorry, they're going to have to be squared, aren't they? Because it's D squared. So I'm going to change this to meters just because that's the unit we're used to. So K equals FD squared, 1.2 times 0.04 squared will equal 0.0192 meters squared. The mark scheme says you can allow the centimeter squared in its unit. The magnets are held the same distance apart, but the north pole of one now facing the south pole of another. The value of K does not change. Okay. How would the force compare? Well, before it was repulsion, now we're going to get attraction. So it'd be the same size, but the opposite direction. So it'd be attraction rather than repulsion. But we've got this idea they would be the same size, which is what it tells us. The value of K does not change.